Hi Stat students, this is our second video. This is part 2 of the chapter 8 packet. We were talking about interval estimations, we still are, and we talked about the fact that we have 3 types. We have the type where sigma is known, which is what we covered in the last video. We have this video where sigma is unknown. And then in this video, we are also going to cover proportions. So we're going to finish the packet today, and that way you can get started on your Wiley, get your homework and your quizzes done. Okay, so in this case, this is really the most applicable to real world situations. Because if you think about it, the reason we're doing interval estimation is because we don't know the population mean. And so we're having to estimate things about the population. So it only makes sense that we wouldn't know the population standard deviation in most cases either. So this is what is really used the most in the real world of statistics. And so it's going to be very different. We are not going to be focusing on Z any longer, or the Z table or the Z chart, but instead we're focusing on T. So that's where this little guy comes in. Whenever you are using sigma unknown, we are not going to use this guy. This is for Z. We are going to use this chart. So remember, this is a new chart that is under content in Blackboard. It's under test 4. It's called the degrees of freedom chart, or the T table. You'll see the T up at the top here. I know it resembles the Z table a little bit, but it is different. Over here on the left, you have what we call degrees of freedom. Across the top, you have the area under the curve. And here in the middle, you have T values. And so that's true of both sides. Now notice the areas only run across the first page. When you flip the page over to get the larger degrees of freedom, you don't have those areas. So I went ahead and wrote them in because I needed a little help there. I don't have you guys to keep me on track anymore. So you may want to do that, but you are gonna need this table. The other thing that's kind of interesting to remember about the T table is that with the Z chart, we were always looking at areas to the left. Well, look right here. With T, we're looking at areas to the right. So it's a little bit different as far as T is concerned. We're looking at area in the right tail. Okay, so we'll get back to that in just a second. So for samples where the population is approximately normally distributed and the standard deviation is not known, remember sigma is unknown, we are going to use the T distribution. Okay, this distribution has one parameter. It means one thing we need to know, and that is the degrees of freedom, also known as DF for short. This is completely dependent on the sample size. So the degrees of freedom are equal to n minus 1. And we can do this when we are assuming that our distribution is approximately standard normal, where we have that 0 right there in the middle. Okay, now a couple of things we also want to talk about is that if we are in the right tail of that curve, T is positive. We know that. Anything to the right would be a positive Z, so it just makes sense that you would have a positive T as well. Okay, it also makes sense that anything in the left tail, just like with Z, would give you a negative T. Now, if you notice all of these values that you see for T on both sides of this chart, they're all positive. That's because these are all for the right tail. You are always going to assume that we're dealing with the right tail unless it specifically tells you you're in the left tail, and it won't do that very often. You may have 1 out of 10 questions that say that, and we'll look at what that means in a little bit, but basically it just means you make your T negative. You look it up as the positive version and you make it negative. But otherwise, we are always going to assume T is positive. Okay, so how do we find this t from this distribution table? Well, there's 3 steps. So your first step is that you want to make your confidence level, that percentage, you want to make it a decimal. So if you have 95% confidence level, then your decimal is 0.95. You're just going to divide by 100 or move your decimal point 2 places to the left. Okay, step 2, once that is a decimal, you're going to use a little formula, 0.5 minus this confidence level that's a decimal now, divided by 2. Okay, this is the area. So these little areas that you see here across the top, it's going to be one of these 6 choices, always. Okay. All right, and then number 3, last but not least, you need to find the degrees of freedom. And we already said that's just sample size minus 1. So this is going to help you find t. Okay. Now, once we find t, we're going to use it in our margin of error. So if you remember, our margin of error for z, or for a sigma known, was just z times sigma x bar. Well, here we're looking at t times sx bar. That's going to give you your margin of error. So s of x bar is found right here. It's s over square root of n. Now, since we don't know sigma, we're going to replace it with a little estimator called s, the little estimator s, okay? So that's what we are replacing it with, which would be the sample standard deviation, okay? All right, so I think we're just about ready to get started. Some of you really liked that I had some little steps written here. So why don't we do that again? If sigma is unknown, let's write a few steps in here. Here we go. Okay, might be a little high for you. Let me lower that just a little. There we go. Okay. All right, first thing we're going to do, we are going to find s of x bar. That's going to be s divided by the square root of n. Okay. Second step, we're going to find t from our table. All right, well, there's 3 steps to find him. First step, we just did this, make our confidence level a decimal. Okay, sorry about that line there. Make your confidence level a decimal. All right, number 2, we are going to use this little formula, 0.5 minus the decimal divided by 2. Now notice only the confidence level is divided by 2. So you're going to need to do that divided by 2 first, then 0.5 minus that. Be careful in your calculator. That's going to be your area. Okay, make sure you guys can see this. Sorry, I'm kind of writing right off write that over as the area. That's what that says. Okay, I'm writing a little too big. Sorry, guys. All right, and then step 3, find your degrees of freedom, which is n minus 1. Okay, that's going to give you t from your table. Okay, step 3, you're going to find the margin of error. It's going to be t that you found, and it's going to be a positive t, okay, times s of x bar. And then last but not least, you're going to take x bar minus e, x bar plus e. This is going to give you a nice little interval. And there you go. Okay, so this gives you a little succinct area that tells you exactly what your steps should be to come up with the answer. So that's what we're looking at. Okay, all right, let's go back to our paper. Here we go. Okay, we'll go down here and we'll start with this example. Okay, so for n equals 25, x bar equals 186, and s equals 12. it's what's telling me sigma's unknown. That is the clue. And here's our confidence level that we want. It's 95%. Construct the confidence interval for the mean. Okay, here we go. Step 1, just like with our little cheat sheet over here, we want to find S of x bar. Okay, well, S is 12, divided by the square root of n, which is 25. We're going to go out 4 decimal places just to make sure that when we put it into our calculator that we're covered. Okay, all right, now we go on to B. Find t for this example. N equals 25. Okay, so if we follow our steps here to find t from the table, first step, make our confidence level a decimal. Okay, so step 1 would be that our confidence level becomes a decimal, 0.95. Okay, step 2 says we're going to use this formula. Okay, we're going to do 0.5 minus our decimal confidence level over 2. Okay, be careful here. This is really where the parentheses ought to go. This is going to give us 0.025. Okay, 0.025, that's going to be the area at the top of our t-chart, 0.025. Okay, there we go. All right, then last but not least is our degrees of freedom. Okay, so this is going to be last but not least, our little steps here, n minus 1. N is 25, subtract 1, our degrees of freedom are 24. There we go. Okay, so now we want to, oh, this is where I was supposed to put the area in the tail. All right. We'll put that right there. Okay, so from the t-table, here we go. We have an area and we have a degree of freedom. So we'll put our table here. Okay, I'm going to go down till I get to 24 as my degree of freedom. There it is. Okay, then I'm going to look over that line. Okay, and I'm looking for, my area was 0.025. Here's my area. So I go down till I get there. Here's my degrees of freedom. This is my t, 2.064. And I leave it positive because I was not specifically told that it should be different. Okay? And you very, very rarely will be. So my t is 2.064. Here was my area from the top, degrees of freedom on the side, and we're off and running. Okay, now, third step, find E. Okay, so I'm going to take T, 2.064, and I'm going to multiply that by S of x bar. I do that, and I get a nice margin of error, 4.95. Then I'm going to take x bar, which was 186 here. I'm going to subtract my margin of error, and I'm going to take 186, and I'm going to add my margin of error. And I'm going to get an interval of 181.05 is my lower, comma 190.95 as my higher. And that interval that you see right here is your answer. So, very similar. This is very similar, just an S instead of a sigma. This is very similar. The T is what's different. We can't automatically look at a chart given the confidence level and come up with a value. We actually have to do a little bit of work for that. So that is what's different when sigma is unknown. Okay, now I did want to talk to you a little bit about the chart. If you turn it over, okay, we only have what we have here, right, with our areas. But if you continue down your degrees of freedom, notice we only get to about 75. Well, I guess it would help if I moved it so you could see it. I'm really not doing great on this video this morning. Okay, so we are going down here. We really only get to about 75. And then look what we see, an infinity symbol. That's because anything from 76 all the way up to positive infinity has these same values. Once we reach a certain sample size, a sample size of 76, right? 76 minus 1 is a degree of freedom of 75. After that point, anything larger than that, they all have the same values. So that's just something to consider if you are on Wiley or something like that and you end up with a very large degree of freedom and you don't see it on the back. It's because anything from 76 larger, just use this row in the corresponding area to find your T. Okay. All right, let's turn over. Here we go. A few more examples here. This says construct a 99% confidence interval for the same data. Okay, well, our S of X bar is going to be the same because they said it was the same data. And S of X bar is S over the square root of N. So that's not going to change. That's what we had on that previous example. Okay, T is going to change. Why? Because we have a different confidence level. Okay, so remember, we're going to have to go back to this and we're going to have to come up with a T. Our confidence level is going to be different when we put it in this formula. So that's going to give us a different area. Okay, so here we go to find our T. We'll just kind of do it up here like this. We're going to have a confidence level of 0.99 because we're going to take 99%, we're going to make it a decimal. Then we're going to use that formula, 0.5 minus 0.99 divided by 2. We're going to do this first, 0.5 minus that. I'm going to get an area of 0.005. And then what doesn't change is the degrees of freedom because our N did not change. So N was 25, 25 minus 1, 24. So that did stay the same. Okay, let's go to our chart and let's find our T. So turn it back over here. Okay, degrees of freedom did not change. Here we are at 24, but we're going to have a new column. We said that our area is now 0.005. We're down here. We go down the column. This is our new T, 2.797. Okay. We're going to take that, put that in as our T, 2.797. All right. Now we need a new margin of error. Remember, your margin of error is T, the new T, times S of X bar. Okay, so we are going to have our T times S of X bar. We end up with 6.71. Okay, now last but not least, to get our confidence interval, we take X bar plus or minus. Now X bar is the same data from the previous example, so that was 186. 186 minus 6.71, 186 plus 6.71. And then I'm going to put the answers right over here in this little interval. So 179.29 was the lower value. 192.71 was the upper value. There we go. This is our answer. So what does that mean exactly? Well, for 99% confidence interval, for a confidence level, this is your interval. For a 95% confidence level, this is your interval. So what we're trying to show you with that example then is that the same thing that applied to sigma known also applies to sigma unknown. And that is, as your confidence interval increases in width, it gets larger, that interval, your confidence level also increases. Remember, they both increase. Okay, they both increase, and vice versa. So there's a direct relationship. As that confidence level goes up, your interval gets bigger. So just keep that in mind. Okay, let's go on to number 1. Okay, so this is sort of the start of the additional examples here. And I had mentioned to you that you may occasionally be told that you have a t in the negative tail. So let's look at what happens there. Find the value for t with a sample size of 14, okay, and an area in the left tail equal to 0.025. Left tail, here's your area. Okay, so if my sample size is 14, my degrees of freedom are going to be 13. I have the area, it's already been given, but because this is the left tail, this means when I find t, I'm going to make it negative. And that's all they want, is find the value for t. Okay, so I'm going to go to my chart. I'm going to go down degrees of freedom until I get to 13. I'm going to go across until I find the area I'm looking for, the 0.025. Here we go. 2.160. Remember, these are all the positive versions because they're in the right tail. So instead of positive 2.160, our answer is going to be negative 2.160. And that's our answer. Okay. All right, number 2, find the value for t. Again, we're just using the chart. We have a sample size of 22. Well, we know we're going to need degrees of freedom, so we're going to subtract 1. We get 21 degrees of freedom. In an area in the right tail, okay, this means t is positive, so we're going to leave it alone. And here's our area. So we're going to go to our chart. We are going to go down to degrees of freedom of 21. We're going to go across until we get to 0.1. It's the very first column. Go down. Here's our t, and we're going to leave it positive. 1.323. We leave it positive because it said right tail. Now again, we always leave it positive actually, unless it says left tail, and you very rarely will see it, but you will every once in a while. Okay, that brings us to the doozy down here. This is quite the doozy, and you're going to have this on your test. This is going to be an oldie here. It's going to take you back. You're going to have to go all the way back with your graphing calculator to good old 1var stats. Remember that guy? Good gracious, that was a long time ago. All right, so let's read what we have. Okay, a sample of 6 observations. All right. Okay. Here they are. Taken from a normally distributed population, produced the following data. There. Wow, that's it. That is all they gave you. Well, what do they want you to do with that? Well, they want you to find the point estimate of mu. Well, that was way back on the first page. What is the point estimate of mu? X bar. Okay, so the point estimate of mu is X bar. That's what we're trying to find. Well, I don't have that, but I do have 6 values. Okay, so we can do one of two things. We can take it old school and know that X bar is just the average. We can add these up, divide by 6, and you're going to get a nice little X bar of 23.817. Okay. Another way we can find that is we can use our graphing calculator and we can use 1-var stats. Now, why do I bring that up if that's all we have to do? Well, because that's not all that we have to do. There is no X bar or S given. You must know both. That's the problem. We have a sample, so we're not going to find sigma, but we are going to be able to find the sample standard deviation. Now, X bar was easy enough to find on our own. We know that's the average. We add them up and divide by 6. Remember, S, that's the one that's a real pain in the butt. That's that square root of, well, I'm just going to put my notes right in here because it is such a pain to read. But here's that crazy formula for S. Well, I don't want to do all that because that is way too much work. So my suggestion to you is put that in your calculator. Let's do 1-var stats and let's get this information. Okay, so let's see if we can remember how to do that. Remember that you are going to use stats and you're going to use lists, right? So here we go. Let's see if we can remember. All right, so here we are going to go to stat, okay, and we're going to use edit. All right, well, I have a bunch of stuff in mine, so I'm going to go up here, clear them out. Okay, I only need one list to put these 6 values in. Okay, so let me go back over here and edit this. We went to stat. Okay, we went to stat, and then we went to edit, and we put them all in L1. Okay, so here we go. All right, I'm gonna go stat, edit. Here I am at L1. I'm gonna do 24.7, 21.3, 25.4, 22.6, 23.7, and 25.2. We're all in there now. Now we're going to quit. Okay, now we're going to quit. All right, now remember, once you quit, okay, so I'm going to put quit right here. Okay, we're going to quit. Then you're going to have to go back to stat. You're going to scooch over to calc. And then you're going to do 1-var stats. And when you do that, all you're going to put is L1. That's it. Okay? Your frequency list is going to be blank. You're not going to put anything else there. And you're just going to hit those. So here we go. Okay. I quit. I'm going to do stat. Scooch over to calc and hit 1-var stats. Then all I want here is L1. If you have that older version, like the one on my computer screen that I put up there, all you're going to put is L1 and hit enter. We don't want anything else. Everything else should be blank. And when we do that, lo and behold, we have what we need. Now, you have to be really careful here. Okay, here was X bar, here's X bar. So we could do it by hand, or we could pull it right from 1-var stats. Now we have X bar. That's our point estimate of mu. Okay. The other value that we needed in order to find a confidence level is S. Now be careful here. In 1-var stats, we have SX. See that? In 1-var stats, it's SX. So this is not S of X bar that we're looking for. We still have to calculate it. This is actually S. It's just that's the notation the calculator uses, okay? So S of X is 1.6142. Take that out 4 places, okay? And then you're done with 1-var stats. You're done with that. You needed it for 2 items. You needed X bar and you needed S. Now, if you don't have a graphing calculator at home, if you were borrowing someone else's, you can always go online, and they have all kinds of little calculator applications online that you can use. So that's an option for you. Okay, so there we go. All right, so we need a 90% confidence interval. Okay, I'm going to kind of move that over there. Okay, so remember the calculator is going to write it as S of X, but it's just plain old S. So we need to make sure you realize that. Okay, so first thing we need to do, find S of X bar. Okay, here's our S. We just got it from our calculator over square root of n. Remember, n is 6. And we're going to take this out 4 decimal places also, all the way over to 0.6590. Okay. Next, we need to find t from the table. We need to go through these steps. Well, our confidence level is 0.90. Okay. 0.90. We're going to need an area. Our area is 0.5 minus 0.90 over 2. When we do that, we come up with an area of 0.05. And our degrees of freedom are just going to be 6 minus 1, which is 5. Okay, using all of this info, we're going to go to our T-chart. We're going to go down here. Degrees of freedom is 5. We found an area of, let's see, 0.05. Here's our T, 2.015. Okay. All right. Okay, then we want to find our margin of error. Well, I am really running out of room here, kiddos. I'm going to scoot this paper up a little bit and have to kind of write on the paper down here. Okay, so our margin of error is going to be T. Oops. It's going to be T times S of X bar, which we calculated. Okay, that gives us a margin of error of 1.3. You could call it 3. I'm going to just take it out a little further. With this particular problem, it's always a good idea to keep bringing it on out because we have abbreviated so much and estimated so much here. Normally, I just do my margin of error to 2 places, but with this one, I'm going to keep going. Okay, then last but not least is our confidence interval. We're going to take X bar plus or minus E. Here's X bar. We are going to subtract 1.3279, and we're going to add 1.3279. That's going to give us a nice little interval that looks like this. And there's our confidence interval. So that one is a doozy. That one will pop up on Wiley, and it will also be on your test. So when you see a problem like this that only gives you pieces of data, that's it, this is what we're dealing with. Count your pieces of data, that's your N. Put them right into a list. Follow these instructions over here. You're going to put them right into a list, then quit. Use 1var stats. That 1var stats is going to give you X bar, and it's going to give you S. Now remember, in the calculator, it's going to say SX, but that's just plain old S. Then you're going to go through your steps. So you have to find the normal information that's normally given to you. You have to find it yourself in this case, and then go through the steps. So it is a little bit more work. So make sure you're prepared for that. Practice that in Wiley, and we'll also practice it on our study guide. Okay, well, that brings us to 8.4, which is the very last section in this chapter. I mentioned to you that we were going to have proportions. Well, here are the proportions. This is what we use when we have very large samples, very, very large sample sizes. We switch over to proportions. Okay, I'm going to switch out these papers underneath because you can tell I'm at the college, because I want to be able to write on them those kind of little cheat sheet things that we kind of liked. And I'm going to try to make sure you can see it when I do that. Okay, there we go. Okay, so for proportions, what we're going to use, we'll go right back over here. We're going to know it is a proportion because you're going to get a percentage. You're going to have a P. Your first step is going to be find S of P hat. So remember, we had to find sigma x bar when sigma was known. When sigma was not known, we had to find S of x bar. Well, now we're finding S of P hat. Okay, so in order to do that, we're going to take P hat times Q hat over N and take the square root of it. Okay, step 2, we're going to find Z from chart given our confidence level. So that's right, we're not dealing with T anymore. We're back to this good old chart where we just get the confidence level, we go right to our Z value. So with your estimate intervals or your interval estimates, the only time you have to worry about T is when sigma is unknown. Other than that, you get to use this little chart. Okay. Then we're going to find our margin of error. It's going to be Z times S of P hat. And last but not least, we're going to take P hat minus E and P hat plus E. And that is going to give us our little interval. Okay? And remember, your percentage, well, you can't really see that, so I'll put it back over here. Your percentage that they're going to give you, that is your P hat. Okay? All right, here we go. So we'll refer back to our little cheat sheet as we need it. Okay? This gives you S of P hat. We already talked about that there so that we know how to deal with that. Okay? Here's our margin of error. We talked about that there. We know how to find all of this. We're going to use that chart we made. So let's jump right in. The only thing you might not be aware of, and let's just make sure we write it on here, is that the percentage they give you is going to be P hat. You just need to change to a decimal. Make sure you change that percentage to a decimal. This percent is going to be how you know we have a proportion. And then Q hat is going to be 1 minus P hat. So let's talk about these little hats for a minute. So we already did proportions in chapter 7. We had P and we had Q. Those all related to populations. So P relates to a population. Q relates to a population. When they start to wear these funny little hats, and that's actually what we call them, our hats, then they relate to a sample. So that's why we're using them. We have sample information and we are estimating. So P hat relates to the sample, Q hat relates to the sample. So that's what we're dealing with. Okay, so, all right, let's say 44%, oh, we've got a proportion because we have a percent. Of a sample of 1,000, yep, that makes sense because proportions use large samples, that's our N. People say religion is very important to them. Okay, find a point estimate for the population proportion. Okay, So here's where let's really make sure we're comfortable with point estimates. For point estimates, X bar is your point estimate for mu. Whether sigma is known or unknown, X bar is the point estimate for mu. Once you have proportions, P hat is your point estimate for P. Okay, and what does that happen to be? 0.44. Okay, because we take the percentage, we change it to a decimal, that's P hat, that is your point estimate. This P is your population proportion. P hat is the point estimate for that. It's your sample proportion. Okay, Q hat is 1 minus P hat. So 1 minus 0.44, that's 0.56. Okay, now we want to find Z. Well, in order to find Z, I need a confidence level. It's not 44%, that's your P hat. You're going to have to read on through the problem. And if you read ahead, I see a confidence level of 99%. That's what you're going to use. So I'm going to go to my chart for 99%. I'm going to use that circled value, and 2.58 is my Z. So remember, this is a 99% confidence level on your chart. Okay. All right, now we are going to need to find S of P hat. Okay, that's this formula up here. Remember, that's this guy right here that we're trying to find. Okay, so I'm going to do a big square root. I'm going to have P hat times Q hat over, here's our N, it was 1,000, 1,000. Find this value first and then take the square root of the whole thing. The 1,000 in the denominator, he's also under the root. This is the root of the whole thing. Okay, we're going to go out 4 decimal places, and there's our SP hat. Okay, now we want the margin of error. Well, here's our margin of error. It's the Z that we found times S of P hat. So we're going to take this 2.58 times S of P hat. We're going to go out 4 decimal places. There's our E, margin of error. Okay, now we want a confidence interval. Okay, so we're going to take P hat, which was 0.44, and we're going to subtract our margin of error. And we're going to take 0.44 and we're going to add our margin of error. That's going to give us, and they like it to 2 decimal places for this guy. Wiley will tell you, just pay attention. There's our interval. Now, sometimes with proportions, they don't just want the interval. They want the percentage. So how would I take this to a percentage? I would just multiply by 100%. So they may want you to put it's 40% to 48%. Okay, so they may want you to take this interval and multiply 100 and turn it into a percent. Sometimes they do that simply because P hat was a percent. You started with a percent. Okay, so it'll tell you exactly how it wants it, either the interval or the percent. All right. Let's try our next one. Okay. All right, next example. N is 2,000. Again, you see those big giant sample sizes with proportions. Okay. P hat, we don't even have to change it. Here we had to make it a decimal. Here we already have it as a decimal. So how are we going to find Q hat? Remember, Q hat is 1 minus P hat. So 0.37. Okay, now we do have to do some calculations here for SP hat. Remember, it's this formula up here. It's that first step in our proportion that we're looking for. Okay, so I'm going to have 0.63 times 0.37 all over 2,000. I get that answer. I take the square root. And my S of p hat is 0.0108. Okay. Now I want the Z for a 97% confidence level. Okay, that's where our chart comes into play. 97%, our Z is 2.17. Put that right in there. Margin of error, Z times S of p hat. Okay, so 2.17 times S of p hat. Let's go out another 4 places. Again, these are really tiny little numbers that have been abbreviated a lot. Okay, and then our confidence interval is going to be p hat, which is 0.63, minus that margin of error, and 0.63 plus that margin of error. Okay, that's going to give us a nice interval of 0.607 and 0.653. I apologize for these decimal places, not really following any rhyme or reason, but again, just pay attention on Wiley and it'll tell you how many to take there. Okay, if it wanted a percent though, instead of the confidence interval, we would multiply both of these by 100 and we would round to a whole number. So our percentages would be 61% to 65% if that were the case. All right, so I'm hoping that you're seeing a pattern in this, that no matter which which one of the three you have, you are having to find the standard deviation of that sampling distribution, whether it be sigma x bar, S of x bar, or S of p hat in this case. You are having to calculate that every single time. Then you either find Z from the chart if sigma's known, or if you have a proportion. If it's not known, you follow the 3 steps and use the t-table. Then you're going to multiply the 2 values you get together to get your margin of error, and then you subtract it and add it to your original point estimate, whether that's x bar or p hat, and you get an interval. So same steps over and over and over, even though you have 3 types of problems. Okay, now there is one more situation we need to look at. Okay, so we did mention briefly before, back at the beginning of the packet, that when sigma is known, we can work backwards and find the sample size required to give us the margin of error we want. Okay, well, we can also do that when we're dealing with proportions. And so your formula is going to be n equals, oops, I wrote on that, z squared times p hat times q hat over e squared. Okay, you would only use this when you're dealing with proportions because that's the only way you're going to have a p hat and a q hat. Now notice in the other equation for a sample size, every term was squared. In this equation for a sample size, z is squared and e is squared. P hat and q hat are not squared. So just take note of those little changes there. Okay, here we go. So let's do an example of this so we can see how it works. So it says, find the sample size needed when you have E equals 0.03. Okay, that's a weird little p hat. I don't know where I found that, but he is wearing a hat. So that's 0.32, okay, and a 99% confidence level. Okay, so if I want q hat, I'm going to do 1 minus p hat. So I'm going to do 1 minus 0.32 and I get 0.68. I'm also going to need z for my formula. We said we have a 99% confidence level. Here's 99%. Our z is 2.58. and it wants n. And remember, we're always going to round up. So here we go. We'll come over here. We have a little bit more room. We're going to do z squared, 2.58 squared, times p hat, times q hat, running off the page a little bit, all over 0.03 squared, the e squared. Okay, put that in your calculator. I came up with 1609.37. So what is my final n going to be? I've got to round up to a whole number. 1610 is what I end up with as my final n, my final sample size. Okay, well, this next part here, very important. Make sure you notice this. What if we need a sample size, but we just really don't have a lot of information? And when that happens, what we can do is use a conservative estimate. When you see a problem asking you to use a conservative estimate, my lights went out there, guys. When you see that means we don't know p hat and q hat. We're not sure what they are. In that case, we're going to use 0.5 for each one. We are going to say p hat is 0.5, and we're going to say q hat is 0.5 in both cases, okay? Whenever you see conservative estimate, if it doesn't say that, use what they give you, okay? All right, well, let's do 3 more examples, and then we are done with chapter 8. So first thing we want to do is, let's see, do we get to practice that at all? I don't think we do, but you do get to practice it on Wiley. Oh yeah, we do get to practice it right here, a conservative estimate. Okay, all right, so number 1, these are additional examples. So we have an n, he's kind of tiny, he's not huge, but I notice I'm dealing with proportions because I have a p hat, okay? It says, is the sample size big enough to use the normal distribution to make a confidence interval for p? Oh my gosh, that sounds a whole lot like the CLT, right? The central limit theorem. We haven't thought about him in over a month. Well, he's still around. So here's the deal. If it asks you, is it big enough? What you're looking at is, does n times p hat give you a value bigger than 5? And does n times q hat give you a value bigger than 5? Those are the requirements necessary for the CLT when you're using proportions. So we have an n, we have a p hat, let's get a q hat. Q hat is going to be 1 minus p hat, so that would give us 0.75. Okay, let's test both of these. So they both have to work, okay? So n times p hat is going to be 275 times 0.25. That gives us 68.75. Well, yes, that is definitely bigger than 5. All right, let's just make sure that n times q hat is the same. 275 times 0.75. That one's going to be even bigger. 206.25. So your answer is yes, absolutely. Okay, they are big enough. So just wanted to remind you that central limit theorem hasn't gone away. Here's how it applies to proportions, so don't forget about him. All right, let's look at number 2. What is the sample size? So we're trying to find n. A conservative estimate, oh, this tells me that they don't know p hat or q hat. So I'm using the sample size formula for proportions, and p hat and q hat are unknown, and we want a conservative estimate. That means p hat is 0.5 and q hat is 0.5. Remember, together they add up to 1, so that makes sense. All right, that would limit the margin of error to within 0.27 of the population proportion. This is E. I know it's written in a very strange way, but that's your margin of error. For a 95% confidence interval, there's your Z. So you're going to go to your chart. You're looking up 95%. Your Z is 1.96. Okay, and now we're just going to fill it in and see what we come up with. So I'm going to put in 1.96 squared times 0.5 times 0.5. And again, I'm only doing that because it said conservative estimate. It did not give me a P hat or Q hat. Otherwise, I would use whatever they give me. And your margin of error in the bottom squared. Okay. All right. Put that in your calculator, work your magic, round up to a whole number, and an n equals 14 would give you that. Okay. All right. Last problem of chapter 8, number 3. We have a sample of 557 observations taken from a population. It produced a sample proportion, so I know I'm dealing with proportions, of 0.28. Well, what is a sample proportion? What's the symbol for that? That's P hat. Remember, P is a population proportion. P hat is the sample proportion, okay? All right, so make a 90% confidence interval for P. This gives me my Z, okay? If I look up 90% for Z, I'm gonna take that bigger value, that 1.65. All right, there's my information. Now I'm also gonna need Q hat. So 1 minus 0.28 is going to give me 0.72. Okay, here we go. Make a 90% confidence interval, and then we'll talk about this next sentence. All right, we're going to follow our steps. First step, we are going to find S of P hat. Okay, S of P hat is the square root of P hat times Q hat all over 557, that's N. And we're gonna go out, I'm actually going out a little further on this one because otherwise there's not a lot of digits there. Okay, we already found our Z from the chart. Now we're gonna find our margin of error. Our margin of error is just Z times S of P hat. This gives us 0.03119. Again, I'm just going out pretty far on these because the numbers are so very, very tiny. Then last but not least is making our interval. So we're going to have P hat minus the margin of error and P hat plus the margin of error. And we're going to put that smaller value first, comma, the larger value. That is a 90% confidence interval for P. We are 90% sure that the true proportion is in this interval. So that brings us to this next question. Okay. The true proportion is 0.25. Does the confidence interval cover this? All it's asking is this value inside here? And sure enough, 0.25 lies within this range. It's really close to this guy, but he's in there. So our answer is yes. 0.25 is inside the interval. Now, let me also just tell you, sometimes it's not in the interval. So on Wiley, yours may not be in the interval, and you are allowed to put no. That's perfectly fine. When you do the math, sometimes it's in the interval and sometimes it's not, and it doesn't mean the math is wrong. It just means there's a 10% chance it's not. And so this one happened to be, but again, it's not 100% confidence interval. So it's okay if it's not. Just put no and it'll be all right. Okay, well, I'm sorry that I got a little squirrely with the pages and making sure that they fit into the screen. I hope I was able to answer all your questions. Don't forget that my completed packet, though, is on Blackboard if you need it. And please, please, please email me, text me, call me if you have any questions at all. And this week, your job is to get your Wiley done, your Chapter 8 quiz and your homework. And then next week, we are going to knock out Chapter 9. So I will talk to you again soon. Stay healthy. Wash your hands. I miss you.